Hey there and welcome to the Code Wrinkles channel. In this video, I would like to show you how event sourcing and some tactical patterns from domain-driven design might go very well hand in hand together and might help you to build very robust applications. Before we go into code, there are a few things that I would like to emphasize. First of all, the fact that I'm doing a video on event sourcing and domain-driven design doesn't really mean that in whatever application you do, even the simplest one, you have to apply the things that you see in this video. One second thing that I would like to point out is that I am not and I don't consider myself an expert in event sourcing and domain-driven design. Still, there are some concepts and there are some things that I have worked with and that have brought value to some of the applications that I've written. But what's important from my point of view is the thought process behind of what we will do during this video. When it comes to domain-driven design, usually we tend to think in terms of very dogmatic approaches that, hey, I need to implement an aggregate in a certain way and it should look like this or it should do this. Now, the thing about domain-driven design and event sourcing is more about the mindset. So please take what we'll see here and what we'll do in this video, apply your critical thinking and see how you can apply this kind of like thought process in the applications that you are building, what makes sense for you to implement or what doesn't make sense for you to implement or even consider. This being said, let's now move over to Visual Studio and take a look at what we already have. Now here's some code that I have already prepared. This code is not totally new. Recently, I made a video on getting started with event sourcing in .NET using Martin. And the code that you see here is exactly the code as I left it after that specific video. Now, during that video, and please make sure that if you didn't watch that video and if you are new to event sourcing, please pause this video, go to the other one. You'll find it in the description or in a card here somewhere. And just watch it first and then come back here to this one because it will be very important. Now, the thing is, and I have mentioned it during the video several times, is that I just wanted at that point to get started with some concepts of event sourcing. So what I did is I placed basically everything like the logic for creating the events or starting the streams or appending streams to the events in a class that I've called here the athlete service. Now, unfortunately, this approach is not the best one, and I would like to show you or explain you why I mean that. Now, for this first method, that's this register athlete, there's not a big deal because it kind of like really implies what we need to do. We get some information about a new athlete that needs to be registered, so we start a new stream because that would be the first event in the specific stream, and that's basically it. So there's not really a lot to do about that. However, then we have this other method, which is this set initial body info. Now, the whole concept of this one is that if we go here, we can see that, okay, we get some information about the athlete ID. Obviously, we need that. But then we have this height, weight, maximum heart rate, minimum heart rate, and VO2 max. Now, the thing is that these values, they are not just some numbers. They kind of like express a business functionality. They express a certain concept. For instance, if you're doing physical activity, for instance, the weight and the height is something that you might use in order to calculate the BMI. So theoretically, whenever you update one of those, typically the weight, you would also need to update the BMI. Now, the maximum heart rate, once again, it's kind of like, okay, that's the maximum heart rate that my heart can go on. And it's usually also related somehow to age, so it decreases. But the idea here is that the maximum heart rate is always in a certain range. So you cannot have a maximum heart rate of, let's say, I don't know, 20 or 30. For the mean heart rate, it's exactly the same. You can't really have a minimum heart rate that's probably below 30. This would mean that you are probably dead. And also, you can't really have a minimum heart rate above 90 because it's considered not normal, and above, I don't know, 100 and 120, probably you would also be dead or very, very ill. So definitely there is some business logic to that. Now, for the VO2 max, once again, that's a value that might change, but there's also still a certain range. You see, the core idea here is I don't want you to be an expert on sports right now, but the idea is that behind these numbers, there is actually some logic. So if we go back here to the service, what we actually do here is just simply, okay, I get this information. I see in this bad information that I have a weight value. So I just fire a new event, this athlete weight updated, and that's it. I have a height value. Okay, I just fire this new event and that's it. And the same goes for all the other things that I have here, and then I simply append all the events to this specific stream. Now, there is a problem here, because what if here in this body info update, well, we might have values that are not permitted, that would put the entire athlete model, like the one that we have here, on an invalid state. So that would not be okay. Now, what can we do about that? Obviously, what we could do is we can simply, I don't know, have here some validations, some checks, and so on and so forth, and then simply just not firing this event. But then maybe I have other methods that kind of like want to do the same things, but from other functionalities. So how do I do that? And besides this aspect of consistent state in my application, there is also another challenge. It would be a nightmare to test this method, because hey, we just fire here some events, but how do we know if kind of like the athlete that results when we aggregate those events back is in a correct state or is in what we expect? So what we'll end up having here, we either mock the entire Martin stuff here, or we need to perform real integration tests and have all the real deal happening, and then, well, re-aggregate the athlete and check if everything is the way that we intended to set via this set initial body info. And I think you already see the direction in which I'm going, because the obvious question is, what if we could have, let's say, some central place in which we could guarantee the state or the consistency of our athlete, of our model? And guess what? If we think about domain-driven design and some of the technical patterns, we actually have a concept like that, which is the idea of aggregate and aggregate root. And I have different other videos on domain-driven design and what an aggregate is and what an aggregate root. So please go to those videos. I leave them or the entire playlist in the description for this video below, and you can check them out. So let's go into some refactoring, and without trying to apply very dogmatically really everything that needs to be applied to an aggregate, let's try to see how we can adapt our athlete that it becomes, let's say, a boundary of consistency for the state of the athlete itself, so that it is the single source of truth that can define if a certain event can be applied or if it can't. So let me create a new class here that I will call aggregate root, and let's click create, and here it is. Now let's go one step further and try to consider that all the events that we have on this athlete are actually what we call domain events in domain-driven design. And they actually fit the definition because they are domain events. There are events that happen and that change the state of the athlete, which in our case we'll consider from now on as being an aggregate. So let me also create a class for this one, and I will call it just domain event. Now for now, I will just leave this as an abstract class, and probably I will leave it empty. Just let's say make it as a marker abstract class, so that we know that our events are basically domain events. Now the idea here, you would probably want to add an identifier, because it might be very useful, especially if you want to kind of like integrate or have also integration events and you want to correlate them together. It's useful to have an identifier for the event itself. But what I'll do right now, I'll come back to this athlete event, and here this is a record now. Probably we will have to change that, but I will say that I want this or to be considered as a domain event. So let's change this to a class. So I just updated it to use the primary constructor, and here I have then these properties. Obviously, I would have to make exactly the same things for all of the other events, and that's what I will do right now. In the end, it would look something like this. So we have really a new class for each of these specific events, which are right now considered to be domain events. So we have really for each of them. Now that we have this ongoing, we can go back to our aggregate root and implement a very basic aggregate root idea here, where we would have a read-only list of domain events, which is private. So we hold this into a field. What we want to expose is just a read-only list of domain events. And we also want for our aggregates to be able to raise events. Now, raising events right now means just adding these events or an event to this events collection that we have right now. Now, the next step is to adapt a little bit our athlete to really become an aggregate. So let's go here to our athlete class, and here what I would like to do is make it inherit from our aggregate root. And this would give us access to this method of raise domain event. Now, the idea is that I have this logic here in the service where I can generate events. So what if I can move the decision of what events exactly needs to be generated based on some incoming parameter to the aggregate itself? Because that's the whole idea of an aggregate, to well guard against invariance, to make sure that, okay, I get some inputs, I evaluate them, and I only approve, let's say, a state change only if it makes sense. Now, in this case, approving a state change means just simply raising an event or not raising it if it would put the entire aggregate on an invalid state. So if we go back to our athlete, one thing that we could do here is simply come here and create a new method, for instance, for this set body information. And here in this method, we can now, okay, I have got here some new information. So let me decide, as being the aggregate and being responsible to make sure that the entire athlete instance will not be placed on an invalid state, I can do the necessary business requirements checks and then raise the necessary events if needed, or not raise them if they are not needed. What's the first event that I raise here is this athlete weight updated. So let me go back to the aggregate here. And here, for instance, I can have a simple if statement. And in this if, I can simply make some checks, like for instance, body information weight should be less than or equal to 200. It should be greater than or equal to 40, for instance. And obviously, we don't want to pollute or clutter our event store with events that are not necessary. So we check that if the weight of the body information already corresponds to the weight that we get in as a parameter, we kind of like don't want to raise this event, obviously. But if everything's okay, what we want to do is simply raise this event and we just raise new athlete weight updated. We could even potentially do some other interesting stuff here, and that might help us a lot, especially with the testing, is simply, okay, let's have this raise event, but let's have here first var event new athlete weight updated. And what we'll do here is we will just place the event in this raise event. And why I did this, because what we can do here is we also have an apply method. And in the apply method, we can simply apply the event. And this will change right now, basically the state, for instance, of this entire aggregate. Now, this might be very interesting and important because it should apply only the change for the weight, so it should be okay. But if you want, you can defer applying the event on the aggregate to the end of this specific method, so that kind of like you don't really interfere with the other checks that you need to do here on this body information. But similarly to what we have done here, I will go on and implement similar business checks, or let's call them business rules, because even if others will complain that these are not real business rules because they are not too complicated, from my perspective, they are business rules. No matter how simple they are business rules. So we do the same things for the athlete height updated. In this case, we have other validation rules that we want to have. And once again, if everything's okay, we just raise the new event, and we can also apply to the event to the aggregate. That would help us with the testing part. Now, if we go further, I hope Copilot will help us a little bit here, and it seems it does. Like for this body information resting heart rate, it should be less than or equal to 100. Well, here we just need to change a little bit the value. Let's give it a buffer and let's make it 30. And I don't know, maybe 40. Okay, let's make it 35 here. And this one is also okay. And if the athlete resting heart rate updated, then we just do this. So everything should be fine. Raise the event and apply the event. Now let's see for the next one. Actually, that's the resting heart rate. So the resting heart rate kind of like should have values like this one. Let's make it 110. Obviously, it should be at highest 100, but technically it might be in a tachycardia that you could have probably 110, probably. And the resting heart rate, the lowest, let's make it 35. So I think it should be fine right now. Now for the maximum heart rate, these could be really indeed 230. And obviously here for the lower bound of the maximum heart rate, that should be something like, I don't know, 140 maybe. So we can have this validation like that. And I'm not sure, but I think we don't really need anything else. Oh, we need the VO2 max, obviously. So the same thing here, body information VO2 max, and then it should be higher than 20. Once again, theoretically, you could have, I think, also VO max that's lower than this one. So let's, I don't know, make it 15, and let's make this 100 to allow also for a certain buffer, right? Once again, I'm not 100% a specialist, so I might not know exact values, but I guess you get the main idea behind that. And now that we have done everything here, actually what we can do is we can come back to our service. So we can still keep our service, but we have basically, well, deferred this decision of defining what events needs to be triggered to the aggregate itself. What we can do here is, for instance, let's now come here and delete everything that we have here because we don't want to raise these events anymore. So one thing that we want to do is, first of all, we want to get the athlete. As described in the previous video about event sourcing, this will replay all the existing events in the database for this athlete and will result in having, well, the most up-to-date instance of the aggregate with the current state of the athlete in our application. So now that we have this athlete, what we can do is simply come here on the athlete, and on the athlete right now we have this set body information. But one other thing that we need is to create actually a body information, like var body info equals new body information. This should be named body information, so it should be something like that. Let's go with this on a new line. Now for this one, we also need to generate a constructor because we don't have it right now. So let's generate it. And if we go to the body information, we see that, okay, we have this constructor right now. So everything should be good to go. However, there is one thing, and here is when you're using different libraries or frameworks, there might be some things that kind of like, okay, you need to add in order to make everything work. So in order to avoid having different problems here, let's also provide this default constructor for the body information, and we should be good to go. Now that we have both the athlete and we have the body information, what we can say here is body info, and we just send it here, and we can do this only if this athlete is not null, so we should be good to go. Now, this would mean that in the end, after this method is applied, we will get in the athlete aggregate a list of events that need to be added to our event stream. So what we can do instead here is simply come back here and have here the athlete. And if it's not null, we have here these events. And obviously we also need to specify the athlete.id because we first need to specify the identifier for the stream. But if we get this far, this shouldn't be nullable. Obviously, we would just need to add a check here, but I will avoid it right now. And we just provide the events. And this is how we kind of like do this. Now we have moved everything here in the athlete itself. And we have achieved that whenever we want to change something, all the behavior that changes the state of the athlete is actually part of the athlete itself. So it happens here. And once again, the fact that we can even apply all these events on the aggregate itself makes it easier to test. Because right now, if we want to test if the, well, update of the body information is successful, or, well, if we have bugs, we don't need to integration test the entire method. We can just unit test this athlete and the set body information method by making sure that we provide all the different use cases. Please let me know what you think about this. As I said, it's more important than the code itself that we have written. It's the thought process. So what do you think about this thought process in combining event sourcing with domain-driven design? Does it really make sense? Does it only add complexity that doesn't have any justification? Or do you think that it's actually quite okay? We can bring it even one step further and we can introduce the concept of state machines, which would be a totally different approach. Like, okay, we have an athlete, which is the current state. Then we have a method that kind of like would transition the athlete from one state to the other, and then we can evaluate the state transition. So that would be definitely another possible approach. So what would you do? What do you think about this thought process? Please let me know in the comments, and let's maybe get a discussion going. That would be totally nice. Don't forget to hit the thumbs up button and to subscribe to this channel if you're for the first time here, and also hit the notification bell so that you get always notified when there's something new happening on the channel. And if you have any question or just want to get in touch and just ask or say something, feel free and don't be shy to go to the comment section and leave a comment below, and I would be more than happy to get in touch with you. If you want to get access to the source code, don't forget that all the Code Wrinkles members on Ambassador Hire or Hire will automatically get access to the source code. After each video, you just have to check the membership tab after you became a member, and you will find instructions on how to get it. If you want the source code, make sure you become a CodeWrinkles Ambassador member. This being said, thank you very much for watching, and until the next time, I wish you the very best.